Welcome to Science Plus TV once again. Children, I hope you must have seen my previous video in which I discussed very important reaction called halogenation of alkanes with you. In that video we got to know about what is halogenation of alkanes, and we took the example of chlorination. As I promised in that video, that in the next video I'll definitely come with the mechanism, which is very important. So here we come. Today I'm going to discuss with you the mechanism of halogenation of alkanes. Okay, and that special mechanism is called as free radical mechanism. Children, this mechanism is important as well as interesting too. It's really interesting as you will come to know about its different steps. So let's start with the very first step, that is called as chain initiation. Initiation means beginning, how this reaction begins. So that's a very important part, my dear children. In this reaction there is a formation of free radicals, and that happens how? Let's just check it out. We take a mixture of methane and chlorine gas, and that mixture we can treat it two ways. We can either heat it to 520 to 670 Kelvin in dark, or we can treat it with ultraviolet light at room temperature. We can do either of these. When we do so, what happens? This covalent bond between the two chlorine atoms, that undergoes homolytic fission. Homo means same, lytic means breakage, and fission means to break up. Okay, so homolytic fission means when this bond breaks, this one bond is made up of two electrons, right? When this bond is broken under the category of homolytic fission, two electrons will be distributed equally amongst the two participating atoms, thereby forming two chlorine free radicals, like you can see here. Okay, so that is the chain initiation, where the two chlorine free radicals are formed by either heating the mixture of methane and chlorine up to the temperature between 520 to 670 Kelvin in dark, or by treating them with UV light at room temperature. After this, the chain starts to propagate. This step is quite interesting. Let's just check it out. There are two important reactions that take place. You see, there was the free radical formed in the first step, chain initiation step. Now this chlorine free radical will be attacking any one of the hydrogen atom of the methane. This is the methane molecule, and this hydrogen atom will be attacked by the chlorine free radical. When this chlorine free radical will take away this hydrogen with its one electron, then this one electron will be transferred to this carbon, and it will be converted into methyl free radical, while this H and Cl, they will be removed as hydrogen chloride in the gaseous form that keeps getting removed out of the reaction mixture. Now what this methyl free radical will do? This methyl free radical will attack further chlorine molecule. One more chlorine molecule will be attacked by this methyl free radical. Similar homolytic fission will be taking place here, and this chlorine will get attached to this carbon, forming methyl chloride, and one more free radical, chlorine free radical, will be formed. Right, beta? This chlorine free radical will further attack all the methane molecules in the reaction mixture, forming methyl chlorides. When sufficient amount of methyl chlorides will be formed in the reaction, this chlorine free radical will start attacking the other hydrogen atoms, and thereby these two steps will keep continuing until all these hydrogen atoms are replaced by chlorine atoms. Okay, so this reaction takes place for a couple of a considerable time, because all the hydrogen atoms in the reaction mixture of the methane, they will be removed by the chlorine, and thereby this reaction is called as chain propagation reaction, because in this step the chain reaction continues to happen, removing all the hydrogen atoms from the methane and replacing them all with the chlorine, forming the CCl4, that is carbon tetrachloride. We can just write it like this also. That is the carbon tetrachloride molecule, where all the 4 hydrogen atoms are replaced with the chlorine atoms. Now, when will this reaction stop? So, from this question we come to the third and the last step of this halogenation reaction, that is the chain termination. Now, the chain termination will happen by the combination of different or same type of free radicals together, when no free radicals further will be produced, and hence the reaction will stop. Okay, how can it happen? There are the different possibilities in this. There are chlorine free radicals. They might combine with each other, forming chlorine molecule. There are methyl free radicals. They can attach together, forming ethane. Okay, then this methyl free radical and chlorine free radical, they can combine together, forming CH3Cl methyl chloride. Okay, so this is how this reaction will stop, because you can see there are no free radicals formed. So this free radical reaction will stop here, and this will happen only after all the hydrogen atoms in the reaction mixture are replaced by the chlorine atoms. Here one thing is very interesting. Sometimes you might be asked a question in the exams that why there is a formation of ethane. Why some amount of ethane is produced during chlorination of methane? So here comes the answer. During chain termination process, the methyl free radicals, they might combine with each other, forming ethane. So that is why ethane is formed as a byproduct during the chlorination of methane. My dear children, it's a very important question, conceptual question. It might be asked in the exams, and this mechanism also can be asked many a times. It's very important. So I hope you must have liked it and enjoyed understanding this halogenation of alkanes. See you later. I will soon come up with the next very interesting topic for you guys. Till then, take care. Bye-bye. Stay safe.